For the final sprint of this project, I'll be setting up a private Ethereum network and create the smart contract and the app. I'm now on my laptop, and the first step is to create a folder. I name it Sprint for GIF, but you can name it however you like, and then open up in Visual Studio. Next is to create a GIF account. Open up a terminal and enter this command, and then you will be asked to enter a password and re-enter a password. Once done, you will be shown the address. What you want to do next is you create a text file so that you can paste the address inside there and the password.
I'm on my PC and I'll create another GIF account. Same thing, you create a folder, you can name it however you like, and then you open up in Visual Studio. Open a new terminal and enter this command. Same thing, enter a password and re-enter, and you'll be shown the address. Create a text file and paste the address and password inside.
Enter PrivateEth and then specify a network name. Configure new Genesis. Create new Genesis from scratch. Which consensus? Choose proof of authority. How many seconds should blocks take? If you want a faster transaction, you should enter a lower number, so I'll pick 5. Which account to be sealed? So put in the node 1 address, which is the laptop node, and also the PC node address. So we're telling the Genesis plot that these two accounts will be doing the mining. And then which account should be pre-funded? You can have it pre-funded or not, but I will only be putting node 1 address because I want to show that some sending of ethers later on. Just press enter. Enter a specific chain. Note you can enter any chain ID, just that you do not want to enter this field, okay, because these are the main nets and the test nets. So I'll pick 13. Next, we want to export our Genesis. So choose manage existing Genesis, export Genesis configuration, and which folder, just press enter. And then you can see on the left, the Genesis has been exported. So to get out of PrivateEth, just press Ctrl D and you're out of it. Is the newly exported Genesis. So enter the following command. And then once it's successful, you can
Note, copy the 2 Genesis file over and paste it over here. Then enter the command, this command. You also see that successfully wrote the Genesis.
The private Ethereum network on both nodes, starting from the laptop node. So entering the following commands. And if you're unsure about what these are actually called flags. And then you can find out more in this link here, where is the official GIF documentation. Click enter and you'll be able to see this.
So enter the command here. You need to take note that the port must be different. So the laptop node, we use port 3000, and this PC node we will be using port 3001. Enter, you also see this. So we need to attach the IPC. So look for this URL here, and then open a new terminal and paste this command. And you will see this.
And then copy it. Open in a new terminal and then just enter. And you will also count in the IPC terminal. So in the IPC terminal, enter this command. And once unlocked, it will show true.
To unlock the account for the PC node. So same thing in the IPC, enter this command here. And once it unlocks
the laptop node and the PC node. So I'm on my laptop now, and I will have to get the E node in order for these two nodes to connect together. So enter this command. Then look for this E node over here. Copy it. The IP address shown here may not be the IP address of the node itself. So if you were to see our do IP config in command terminal, in the command prompt 168.18.18. So when we do our adding later on,
so I've copied over the E node from the laptop node. So to add the node together, I will just type the command admin.add here and paste the E node in. And just now we said that the IP address is 192.168.18.18. So over here we have to do the changes. And I press enter and it will show true. Next, before the mining start, we can actually check for the balance. So just enter this command. And you can see 0. So what we're going to do now is we're going to transfer some ethers from the laptop node to this PC node.
To the PC node, and then we just press enter. Then we just press miner.start. We press enter.
Once I enter this, it will not be 0 anymore. Okay, it will be 600 ethers because just now I sent 2 times instead.
The network in MetaMask. So open up your MetaMask, click on add network. You can just give it any name. Just name it give. Then the RPC URL, enter http 127.0.0.1, and as just now we set the port to HTTP, the HTTP port to 8543, so we put 8543. Then the chain ID is the one we've set 13. Currency symbol ETH, and once you're done, just click save, and it will show that it's added successfully. So the next thing you want to do is that you want to import the account. So you press import account, select JSON file, choose the file, go to the directory, go to where the directory is, then select the key store, and then select this file. Then enter the password you've set just now, so it's 123, and press import. It will take a while to load, so just be patient and let it load. On the laptop node, the account has been imported with the balance over here.
Network in the MetaMask for the PC node. So add network, then the HTTP 127.0.0.1 and the same HTTP port 8543. Then the ID and the symbol. Then click save. And then we're also gonna import. The account. Click on JSON. Select key store. Then enter the password 123. It will take a while to load as well. So once it loads, you can see that the account has been imported and with 600 ethers. PC node, you also see the same thing. and they are both trying to mine.
You can see that it's actually starting to mine. This is what the laptop node will see. Created a smart contract in such a way that this contract has two functions. The first one is to register the score, and the second one is to set the quiz questions. So the register new score struct is over here, and the question struct is over here. So I have created an access control right in such a way that for the set question function, only the owner can set the question. If another account tries to set, it will show a message saying that you cannot set the question. Okay, so this scenario is based that whoever deploy this smart contract is the module leader, and the rest of the nodes are just the normal lecturers. So in this case, this network consists of my laptop and my PC. So my laptop will be the module leader, where I will be the one to deploy the smart contract, and the PC will be a normal lecturer. Created a smart contract in such a way that this contract has two functions. The first one is to register the score, and the second one is to set the quiz questions. So the register new score struct is over here, and the question struct is over here. So I have created an access control right in such a way that for the set question function, only owner the owner can set the question. If another account tries to set, it will show a message saying that you cannot set the question. Okay, so this scenario is based that whoever deploy this smart contract is the module leader, and the rest of the nodes are just the normal lecturers. So in this case, this network consists of my laptop and my PC. So my laptop will be the module leader, where I will be the one to deploy the smart contract, and the PC will be a normal lecturer, the smart contract. And I will start so by showing on the laptop node itself, because the laptop node will be the owner of this contract. So okay, so there's two ways to get the contract address. You either can look for the block number, or you can just press here. So if you want to go for the method where you want to see in the block, just look for in your terminal, look for this number 10616, your contract address. So just copy this and then you paste it. Okay, after pasting, open up web server for Chrome, and it will open up the app. So what's the difference between module leader and the normal lecturer? I'll show what they can do and cannot do. So first, module leader, as you can see, is the laptop node. Module leader can view the score, any student score. So it will two simple functions. They can enter the student score, and they can also set the quiz questions. So for the score function, they can view the student score, but the record shown will be all the students and all the random quiz. And it might be, if this module leader wants to look for a particular student, see how his progress and his learning status, it might be a bit troublesome for him to scroll and look through. So there's this search function where they can just search for the name. Let's say I want to look for Xavier. So I press search, and only Xavier quiz and the score will appear. Similarly, if I would look for another student, let's put Samuel, and I press search, only Samuel quiz and the scores will appear. And then you can just reload to go back to normal. And I also can enter a student quiz score. So I just enter else just press enter, and then I can just press confirm, and then a notification would show that you can see it's confirmed. So if you were to press refresh, you can see that the number of records has increased by 1, and the latest record has been added. And I can also search for the latest record here. If there's no student, if I were to enter a student is invalid, it will not show anything. Next is the quiz questions. Is a setting of the quiz questions. So in my scenario, what I have trying to picture is that only the module leader can set the quiz questions, but the lecturer and the module leader can see the quiz questions. So everyone can see this, but if they try to set, only the module leader node, the transaction will be able to pass, and then the normal lecturer node will fail. So yeah, this part is the viewing of the quiz questions. So it has all the quiz and the quiz questions. And if there's also a search button if they want to look for a particular quiz. Let's say tuple, I press search, and tuple quiz will come up. Only tuple quiz will come up, and all the questions will come up. And also they want to look for the questions are the same because I forgot to change. And if I want to look for list, only list quiz, and the questions will come up. And if I enter invalid quiz, it will not show anything. Then to go back, you can just refresh. Okay, so let's say the tuple quiz will need to have 5 questions, and then there's only 4. So this module leader can add a 5th question, and you can just add, and you can enter the number of marks worth for this question, and you press set. And you press confirm. So if we refresh, same thing, the number of records has increased by 1, and we can see that now tuple has a 5th question. So if I were to search for tuple again, tuple will have 5 questions. Okay, so now I will be showing what the other node can do is the PC node. So this PC node would be in the perspective of a lecturer.
PC node now. And just now on the laptop, note that the smart contract was deployed on block 10616. And we need to find that block to get the contract address. So go to the IPC terminal, and then you just enter. First we have to enter it.getBlock. So this way we can get the transaction hash 10616. Press enter. See, copy this transaction hash. The next what we want to do is we want to paste this command here. So this will get us the contract address. So once we paste this and we press enter, and then there we go. You can see the contract address is this. And then we will go to our JavaScript here, and then paste in the address. And then same thing, open up in the web server. Open it up and then just enter square. So same thing, this lecturer can view the score and the quiz. So starting with the quiz, and you can see this is a PC node. So just now the laptop node has added the new record, this one. So they also can see. They also can search for the particular student. And then the quiz and the score will come up. The quiz that they have taken. Then if they were to enter invalid one, it will not show anything. Okay, then they also can add another student's name, and then their quiz scores. Then they can just enter score. Then they can press enter. Okay, so once added, you can see that there has been an increase in number of records, and the latest one has the latest record added is shown in this view student score. So same thing, they can also search for the latest record and it will appear. So next, moving on to the questions. As I mentioned earlier, only the module leader can set the questions. So just now the laptop node has added the fifth questions for tuple, so they also can be shown here. Same thing, they can also search for tuple, and only tuple quiz that has the word tuple will come out. And if I want to search for list, it will come out as well. If I search invalid one, it will show nothing. So moving on to the addition of the quiz. So if let's say I try to add, fifth question, sixth question, and then I enter, and I press set. You can see that we're not able to estimate the guess. There might be error, and if they still want to press proceed, and they press confirm, and then you can see that the contract has failed, so the transaction would not pass and it would not be added into the blockchain. And if I refresh, you can see the number of records is still at 7, and no new data has been added. So this is the difference between the laptop node, which is the module leader node, and the PC node, which is just a normal lecture node. So yeah, the one can add score and add the questions, but the second node, which is the PC node, can only add the student scores, but they cannot add the questions. But they both can view the questions and the student score.
Okay, so back at my this laptop node, the module leader perspective. So just now the PC node, I've added a record, the new student, another student. So in this laptop node as well, it will also show the newly record that has been added from the other node. And same thing, they can also search for the name, then only record. And just now the PC node tried to add the question here. You can see no questions has been added, no new question, is still at 7. So this shows that only the module leader can add the questions. And this is all for the private Ethereum network.